Picture yourself standing at the base of a mountain in Western Java, not one of those dramatic, snow-capped peaks you see in travel magazines or nature documentaries. This mountain is modest, maybe 300 feet above the surrounding countryside, covered in dense tropical vegetation so thick that the sunlight barely reaches the ground in places. The air around you is heavy, saturated with moisture, the kind of oppressive humidity that coats your skin in a fine layer of sweat the instant you step out of any shade. It wraps around you like a warm, wet blanket, making every breath feel like you are drinking the atmosphere rather than inhaling it. Insects hum in an unbroken, droning chorus that fills the air from every direction, a sound so constant and so dense that after a few minutes your brain stops registering it as individual insects and starts experiencing it as a single living vibration radiating from the jungle itself. The smell is rich and complex and layered: decomposing leaves, wet volcanic soil, the faint sweetness of wild orchids growing somewhere in the tangled canopy above your head, and beneath all of it, something older, something mineral and cold, the smell of ancient stone that has been sitting in the dark under the earth for a very, very long time. And in front of you, disappearing upward into the wall of green, is a staircase made of stone, not a modern staircase, not something laid down by a construction crew with cement and rebar and a set of architectural plans. This staircase is built from hundreds of flat, dark, hexagonal columns of volcanic rock, fitted together with a precision that seems far too orderly to be accidental, stacked and arranged into 370 individual steps, climbing the western face of the mountain toward whatever sits at the top. You start climbing. The stones are slick with moss and rainwater, and some of them wobble slightly underfoot, shifting with your weight in a way that reminds you these have been sitting here for a very long time without maintenance. Others are locked in place so tightly, so firmly, that they feel like they were welded to the stones around them by some invisible force. The higher you go, the stranger the feeling gets, because these stones don't look like they were carved by human hands. They look like something else entirely. They look like they grew this way, like the mountain itself produced them, hexagonal pillars of dark andesitic basalt that split naturally along geometric planes during volcanic cooling, creating shapes so regular, so perfectly symmetrical, that your brain keeps insisting that someone must have designed them, even as your rational mind tells you they are a product of geology, not architecture. This is Gunung Padang. The name translates roughly to Mountain of Enlightenment in the Sundanese language spoken by the people who have lived in this region of Indonesia for as long as anyone can remember. The locals have always known it was special. They have been climbing these steps and conducting rituals on the terraces above for generations, possibly for millennia, treating the site with a quiet, deep reverence that suggests they believe something important happened here, something embedded in the stone itself, something they can feel in their bones, even if the specific details have been lost to the slow erosion of time and oral memory. The Sundanese tell a story about a semi-mythical king named Siliwangi who attempted to build a great palace on this hill in a single night. When dawn came before the palace was finished, the structure was cursed and turned to stone. It is the kind of legend that archaeologists typically smile at and move past. But legends have a way of containing truths that are older than the people telling them. For most of the 20th century, Western science paid Gunung Padang almost no attention at all. It was catalogued in a Dutch colonial survey in 1914 by an archaeologist named N.J. Krom, briefly described as a collection of megalithic terraces, and then essentially filed away and forgotten. Just another pile of volcanic rocks in a country that has 14,000 islands and more active volcanoes than almost anywhere else on Earth. Indonesia's archaeological resources were directed at Borobudur, at Prambanan, at the great Hindu and Buddhist temple complexes that tourists from around the world flock to see. Gunung Padang, with its modest height and its strange hexagonal stones, simply did not register as important. Nothing to see here, move along. But here is the thing that nobody anticipated. In the early 2010s, a team of Indonesian geologists decided to look beneath the surface, not at the stones you can see when you climb those 370 steps, not at the terraces that tourists photograph and that local guides explain with well-rehearsed stories about ancient kings and cursed palaces. They looked underneath all of that. They pointed ground-penetrating radar and seismic tomography equipment straight down through the body of the mountain itself. And what they found, or what they claimed they found, triggered one of the most explosive, bitter, and genuinely fascinating scientific controversies of the 21st century. If you're finding this fascinating and want to go deeper into stories like this, make sure to subscribe to our channel so you never miss one. Because what the data appeared to show was that Gunung Padang is not simply a natural hill with some stones arranged decoratively on top of it. The data suggested that the entire mountain, all the way down to its bedrock foundation, might be an artificial structure, a man-made pyramid, buried under thousands of years of accumulated soil, volcanic ash, and jungle vegetation, built not in stages separated by centuries, but in stages separated by millennia. The deepest layers, according to the researchers, dated to more than 14,000 years ago. Some of the readings hinted at construction activity going back as far as 27,000 years before the present. Let those numbers sit with you for a moment. 27,000 years ago, the last ice age was at its absolute peak. Giant ice sheets covered much of North America and Europe. Sea levels were 400 feet lower than they are today. Modern humans had only recently arrived in Australia and had not yet set foot in the Americas. The idea that anyone, anywhere on this planet, was building a massive stone pyramid at that time is so far outside the accepted timeline of human architectural development that when the claim was finally published in a peer-reviewed scientific journal in the autumn of 2023, it did not just raise eyebrows. It detonated like a bomb in the middle of the global archaeological community. And the shrapnel from that explosion is still flying today. To understand why Gunung Padang triggered such a violent reaction from the scientific establishment, you first need to understand what the site actually looks like when you reach the top of those 370 steps, because it is genuinely strange. Even the most skeptical geologist, the most hard-nosed archaeologist who has spent their entire career dismissing fringe theories about ancient civilizations, would have to admit that when you stand on the upper terraces of Gunung Padang and look around, something about this place feels intentional. The site is arranged as a series of 5 terraces, each one slightly smaller than the one below it, stacked on top of each other like the layers of a wedding cake. They are oriented along a northwest to southeast axis, and they are accessed by the central stone staircase you just climbed. On each terrace, The ground is covered with those distinctive hexagonal basalt columns, hundreds of them, thousands of them, some lying flat on the ground in neat parallel rows, others standing upright like fence posts or pillars, others stacked into low retaining walls that define the edges of each terrace. The columns themselves range from a few inches to several feet in length, and they are remarkably uniform in their hexagonal cross-section, which gives them an eerie, almost machine-produced appearance. If you pick one up, and some of the smaller ones are loose enough to lift, it feels dense, cold, and surprisingly heavy for its size, the way a piece of iron feels heavier than you expect, because your brain is used to holding things made of wood or plastic. Now here is where the debate begins, right here on the surface, before you even get to the underground controversy. Columnar basalt is a well-understood geological phenomenon. When lava cools slowly and evenly, it contracts, and the contraction forces cause the rock to fracture into regular polygonal columns, usually hexagonal, the same way mud cracks into polygonal shapes when a puddle dries in the sun. The Giant's Causeway in Northern Ireland is the most famous example. 40,000 interlocking basalt columns stepping down into the sea, looking for all the world like they were placed there by an architect, but actually produced entirely by the physics of cooling magma. Indonesia is one of the most volcanically active regions on the planet. Columnar basalt is everywhere. The Geological Survey of Indonesia has documented hundreds of sites where natural columnar jointing has produced fields of hexagonal stone columns identical in appearance to the ones at Gunung Padang. So when mainstream geologists look at the surface of Gunung Padang, they see a natural volcanic formation. Columns produced by an ancient lava flow, exposed by erosion, and then rearranged and modified by humans in the relatively recent past, maybe 2,000 to 3,000 years ago, to create the terraces and walls and staircase that exist today. In this reading, Gunung Padang is a megalithic site, yes, but not an ancient one. It is similar in age and sophistication to other megalithic sites found across Indonesia and the wider Pacific, built by people who were already farming, already making pottery, already living in organized communities with the social complexity needed to move large stones. The Sundanese people who live around the site have their own explanation, and it is older and more interesting than either the geological or the archaeological one. They call the mountain sacred. They believe it is a place of spiritual power, a location where the boundary between the visible world and the invisible one becomes thin enough to cross. They tell the story of Prabu Siliwangi, the last king of the Sunda kingdom, who reigned in the 15th century and who, according to legend, commanded his followers to build a magnificent palace on this hilltop in a single night. The construction was to be completed before dawn, but the workers could not finish in time. When the first rays of sunlight struck the unfinished palace, it was transformed into stone, its columns and walls frozen in place by a curse, never to be completed, never to be inhabited, standing forever as a monument to the hubris of a king who tried to build something too great too fast. There is a particular stone on one of the upper terraces that the local guides will always point out to visitors. They call it Batu Kekapi, the stone lute. When you strike it with another rock, or even with the flat of your hand, it produces a clear, resonant, almost musical tone, a ringing note that hangs in the humid air for several seconds before fading, as if the stone itself is singing. The Sundanese believe this is the voice of the mountain, a confirmation that the site is alive, that the stones remember something, that the sacred energy of Gunung Padang is still present, still vibrating, still waiting. Geologists will tell you that the ringing is simply a function of the stone's density and crystalline structure. Certain types of basalt, when shaped into the right geometry, can act like a tuning fork, producing clear tones when struck. It is physics, not mysticism. But stand on that terrace, surrounded by thousands of hexagonal columns, listening to a stone sing in the middle of a Javanese jungle, and physics starts to feel like a slightly inadequate explanation for the experience you are having. For decades, this was the state of play at Gunung Padang, a beautiful, atmospheric, somewhat mysterious site that attracted modest tourist traffic, occasional academic papers about its megalithic features, and a steady stream of spiritual visitors who came to meditate, to practice martial arts, or to leave offerings on the terraces. It was interesting but not world-changing. A local curiosity, not a global headline. And it would have stayed that way forever if a geologist named Danny Hillman Nataraja had not decided, in 2011, to point his instruments at the ground beneath the stones and ask a question that nobody had thought to ask before. What exactly is this mountain made of? Danny Hillman Nataraja is not the kind of person you would expect to trigger an international scientific scandal. He is a geologist, specifically a seismologist, trained at the California Institute of Technology, one of the most prestigious earth science institutions in the world. His entire academic career has been spent studying tectonic plate movements, earthquake hazards, and the geological structures of the Indonesian archipelago, work that is about as unglamorous and as rigorously evidence-based as science gets. He has published dozens of papers in respected journals on topics that could not be further from fringe archaeology if they tried. Fault line mapping along the Sunda megathrust, subduction zone dynamics in the Java Trench, seismic risk assessment for the densely populated coastal cities of Java and Sumatra. This is a serious scientist doing deeply serious work in a deeply serious field. He has no history of making extraordinary claims, no track record of chasing headlines, no affiliation with any alternative history movement. But Danny Hillman also grew up in Indonesia. He grew up in a culture that is saturated with stories about the ancient past, about kingdoms that rose and fell before written history began, about sacred sites that contain powers and knowledge that modern people have forgotten. He grew up hearing about Gunung Padang, about the Mountain of Enlightenment, about the cursed palace of King Siliwangi. And throughout his career as a geologist, studying the tectonic and volcanic structures of Java, he carried with him a nagging question that his rigorous Caltech training could not entirely silence. If Gunung Padang is just a natural volcanic formation with some stones rearranged on top, why does it look the way it looks? Why is it shaped like a stepped pyramid? Why are the terraces so regular, so symmetrical, so carefully aligned along a consistent northwest to southeast axis? Natural hills do not typically organize themselves into 5 progressively smaller platforms stacked neatly on top of each other. Volcanoes do not usually produce neat staircases. Erosion does not typically carve symmetrical terraces into the side of a hill. Something about the geometry of the site bothered him, the way a wrong note in a familiar song bothers a trained musician. It was almost right. It was almost natural, but not quite. In 2011, Danny Hillman secured funding from the Indonesian government to conduct a comprehensive geophysical survey of Gunung Padang. This was not an archaeological excavation. He was not proposing to dig into the terraces or disturb the sacred site in any way. He was proposing something much less invasive and, at least in theory, much less controversial. He wanted to look through the hill using remote sensing technology, the exact same technology that geologists use every single day to map underground fault lines, locate mineral deposits, plan tunnel routes, and assess earthquake risks in densely populated areas. Ground-penetrating radar, or GPR, sends short pulses of electromagnetic energy into the Earth and measures the reflections that bounce back when those pulses encounter boundaries between different types of material. Rock reflects the signal differently than soil. Soil reflects differently than air. Air reflects differently than water. By measuring the timing and strength of those reflections, you can build a detailed cross-sectional image of what lies beneath the surface without moving a single shovelful of dirt. Seismic tomography works on a related principle, but uses sound waves instead of electromagnetic pulses, generating vibrations at the surface and measuring how they propagate through the subsurface, creating three-dimensional models of underground structures based on how sound travels through layers of different density and composition. These are standard, well-established, thoroughly understood geological techniques. There is nothing exotic or controversial about the technology itself. It is used in mining operations, highway construction projects, and building foundation assessments around the world every day of every week. The controversy at Gunung Padang was not about the tools. The controversy was entirely, explosively, about what the tools revealed. When Danny Hillman's team processed the first batch of ground-penetrating radar data from Gunung Padang, they expected to see the typical geological profile of a volcanic hill in western Java. Layers of lava flow, interspersed with deposits of volcanic ash and tuff, gradually transitioning downward into the solid bedrock of the underlying formation. This is what Java's volcanic geology looks like in cross-section everywhere else on the island. Layers of eruption products stacked on top of each other over millions of years, weathered and eroded and covered in soil. It is predictable and well understood. What they saw instead in the radar returns made them check their equipment calibrations, swap out their antenna heads, and run the entire survey again from scratch, because the data was showing something that simply should not have been there. Beneath the surface terraces, beneath the obvious archaeological layers that everyone agreed were built by people within the last few thousand years, the radar was picking up additional distinct layers of material with sharp, well-defined boundaries between them. Not the gradual, fuzzy, undulating transitions you see in natural geological formations produced by lava flows and ash deposits. Sharp lines, clear edges, geometric patterns. And in several areas, what appeared to be enclosed voids, empty spaces, cavities within the body of the hill that had no obvious natural geological explanation. Let me explain why this matters, because the technical distinction is critically important, and it is the foundation on which the entire subsequent argument rests. When rock forms naturally through volcanic processes, the layers it creates have specific, identifiable characteristics. Lava flows produce solid, relatively homogeneous sheets of dense igneous rock. Volcanic ash deposits produce soft, unconsolidated layers of fine-grained material that compact gradually under their own weight over time. Weathering and erosion produce gradual transitions between different types of material. smooth curves in the radar profile rather than sharp corners. What you do not typically see in a natural volcanic formation are abrupt, right-angled transitions between materials of very different densities stacked in alternating layers, or enclosed voids at significant depth, or arrangements of dense material sitting on top of less dense material in patterns that repeat systematically across the entire width of the hill. The radar was showing a structure that looked, at least superficially, more like a building than a hill. More like something constructed in deliberate stages over time than something deposited by volcanic eruptions and sculpted by the patient work of rain and wind. Danny Hillman stared at the data and understood immediately that he was looking at something that was either going to make his career or destroy it, probably both. To verify what the radar was showing, Danny Hillman's team drilled core samples down through the body of Gunung Padang. Coring is a straightforward geological technique. You drive a hollow metal tube into the ground, rotating it as it descends, and when you pull it back up, the tube contains a cylindrical cross-section of everything it passed through on the way down, a vertical slice of the Earth's history preserved in order from top to bottom, newest layers at the top, oldest at the bottom, like pulling a straw out of a layered cocktail. When the cores came out of the ground at Gunung Padang, Danny Hillman's team found exactly what the radar had predicted. Distinct layers of material, some clearly natural volcanic deposits, but others containing arrangements of columnar basalt that did not look like they had ended up in their current positions through any natural process the team could identify. In certain layers, the basalt columns appeared to be deliberately placed, fitted together in patterns, mortared with a mixture of clay and what appeared to be organic binding material. Not just randomly jumbled rock, organized rock, intentional rock. Now here is where the story takes its first truly explosive turn. Because embedded within those deeper layers, mixed in with the clay mortar and the soil between the arranged stones, were fragments of organic material, bits of charcoal, traces of plant matter, microscopic remains of living things that had somehow become incorporated into the structure during whatever process created it. Organic material can be dated using radiocarbon analysis, one of the most reliable and widely used dating techniques in all of archaeology. When a living organism dies, it stops absorbing carbon-14 from the atmosphere, and the carbon-14 already in its tissues begins to decay at a known, constant rate. By measuring how much carbon-14 remains in a sample, you can calculate how long ago the organism died. It is precise, it is well understood, and when properly applied to appropriate samples, it is remarkably accurate. Danny Hillman sent his samples to multiple independent radiocarbon dating laboratories, including facilities in the United States, to ensure the results could not be dismissed as the product of a single lab's error. The numbers that came back were staggering. The uppermost layer of construction, the visible terraces and walls that everyone agrees were built by human beings, dated to roughly 3,000 to 3,500 years ago. No surprise there. That is consistent with the age estimates that mainstream archaeologists had already proposed for the surface features of the site. But below that layer, the second layer of what appeared to be constructed material, the one buried beneath several feet of soil and volcanic ash, dated to roughly 7,000 to 8,000 years ago. That is older than the Great Pyramid of Giza, older than Stonehenge, older than the earliest known cities in Mesopotamia, and it was just the second layer. Below that, deeper still, separated from the second layer by more soil and natural deposits, was a third layer of material that the radar and the cores suggested might also be artificial. The radiocarbon dates from organic material in this third layer came back at approximately 14,000 to 16,000 years before the present. And at the very deepest levels they sampled, near the base of the structure where it meets the natural bedrock, there were tantalizing hints of organic material that dated to as far back as 25,000 to 27,000 years ago. Think about what those numbers mean if you take them at face value. They mean that some group of people, began building a massive stone structure on this hilltop in western Java during the last ice age. Not during the Neolithic, when humans were developing agriculture and settling into villages. Not during the Bronze Age, when the first cities were rising in Mesopotamia and Egypt. During the Pleistocene, when giant ice sheets covered much of the northern hemisphere, when sea levels were hundreds of feet lower than today, when the conventional archaeological understanding of human capability holds that our ancestors were small bands of hunter-gatherers living in temporary camps, making stone tools and painting on cave walls. The idea that these people were also building pyramids is, to put it mildly, not what the textbooks say. And it gets stranger, because Danny Hillman's model of Gunung Padang does not describe a single construction event. It describes a structure that was built, abandoned, buried by natural processes, and then rediscovered and built upon again, multiple times over tens of thousands of years. Each subsequent group of builders added a new layer on top of the old one, expanding and raising the structure, using the same basic material, the hexagonal basalt columns that the volcanic geology of the region provided in abundance, but separated by centuries or millennia of abandonment, during which the structure was gradually covered by soil, ash, and vegetation. If this model is correct, Gunung Padang is not just old. It is the oldest continuously modified structure on Earth. A building that was begun before the Ice Age ended and added to, layer by layer, by successive civilizations stretching across 24,000 years of human history. When Danny Hillman presented these findings at a geological conference in Indonesia, the room went very, very quiet. You could hear the air conditioning humming. You could hear someone shift in a plastic chair 3 rows back. The silence lasted long enough to become uncomfortable. And then, slowly at first, then with increasing volume and intensity, the arguing started. Because the implications of what Danny Hillman was proposing were not just historically interesting. They were historically revolutionary. If Gunung Padang was really what his data suggested it might be, then everything we thought we knew about the timeline of human civilization, about when and where, and how the first complex societies emerged on this planet, was not just incomplete. It was fundamentally, catastrophically wrong. The paper landed in the autumn of 2023. It was published in Archaeological Prospection, a well-regarded peer-reviewed journal specializing in the application of scientific techniques to archaeological problems. The authorship list was long and included researchers from multiple Indonesian institutions, as well as international collaborators. The title was dry and academic, in the way that scientific papers tend to be, giving little hint of the earthquake it was about to cause. But the abstract, the brief summary at the top of the paper that most people read before deciding whether to engage with the full text, was clear. The authors were claiming that Gunung Padang was a multi-layered, man-made pyramid with construction phases extending back beyond the end of the last ice age. The deepest layers, they argued, showed evidence of deliberate human construction dating to at least 14,000 years before the present, with some indications pushing back even further into the deep Pleistocene. The reaction was immediate and intense. Within days of the paper's publication, it had been picked up by news outlets around the world. The headlines wrote themselves: "World's oldest pyramid discovered in Indonesia. Ancient structure found beneath jungle mountain predates civilization itself. Scientists claim 27,000-year-old pyramid exists in Java." The story had every ingredient that the modern media ecosystem craves: mystery, controversy, a challenge to established knowledge, beautiful photographs of a jungle-covered mountain with strange hexagonal stones, and the irresistible narrative hook of a lost civilization buried beneath the earth, waiting to be rediscovered. And this is where things got really complicated, really fast. Because the paper did not just attract the attention of mainstream news organizations and academic archaeologists, it also attracted the attention of Graham Hancock. For those unfamiliar with the name, Graham Hancock is a British writer and journalist who has spent decades arguing that a sophisticated, technologically advanced global civilization existed before the end of the last ice age and was largely destroyed by a cataclysmic event, probably related to the Younger Dryas impact hypothesis around 12,000 years ago. Hancock's books, including Fingerprints of the Gods, Magicians of the Gods, and most recently America Before, have sold millions of copies worldwide. His Netflix series, Ancient Apocalypse, reached an enormous global audience. He is, depending on who you ask, either a visionary thinker who is asking important questions that mainstream archaeology refuses to consider, or a pseudo-archaeologist whose work distorts evidence, ignores inconvenient data, and gives a misleading impression of the actual state of scientific knowledge about the ancient past. Hancock seized on Gunung Padang immediately. Here, finally, was peer-reviewed evidence published in a legitimate scientific journal that appeared to support his central thesis, that complex civilizations existed tens of thousands of years before the conventional timeline says they should have. He featured the site prominently in his public appearances and social media posts, pointing to it as proof that the academic establishment had been wrong all along, that there really had been a lost civilization, and that its remains were literally buried beneath our feet, hidden by millennia of accumulated soil and the institutional reluctance of mainstream archaeology to look for things they have already decided cannot exist. The reaction from the archaeological community was savage, not just critical, savage. Within weeks of the paper's publication, letters were being sent to the editors of Archaeological Prospection demanding clarification, retraction, or both. Prominent archaeologists posted lengthy, detailed critiques on social media and academic blogs. The pushback was not coming from fringe characters or jealous rivals. It was coming from some of the most respected names in the field, people with decades of experience in exactly the kinds of dating and survey techniques that Danny Hillman's team had used. And their objections were not vague or hand-waving. They were specific, technical, and devastating. The single most damaging criticism, the one that would ultimately prove fatal to the paper, came down to a deceptively simple question that cut right to the heart of the entire study. When you radiocarbon date organic material found in soil near stones, Are you dating the stones or are you dating the soil? This might sound like a trivial distinction. It is not. It is the difference between dating a structure and dating the dirt the structure is sitting in. And in the case of Gunung Padang, critics argued Danny Hillman's team had made a fundamental, possibly catastrophic, error by conflating the two. The organic material they had dated, the charcoal and plant fragments and microscopic biological remnants found in the soil between and around the basalt columns in the deeper layers, was not necessarily associated with human construction activity at all. It could simply be ancient organic material that had been naturally incorporated into the soil through biological processes over thousands of years. Material that was already old, perhaps very old, when the stones were placed nearby, if the stones were placed at all. Or material that had seeped down through the soil profile from higher layers through a well-documented process called biotubation, where the burrowing activities of insects, worms, tree roots, and other organisms gradually move material up and down through sediment layers over long periods of time. In tropical environments like Western Java, where the soil is warm and wet and teeming with biological activity year-round, biotubation is not a minor effect. It is a constant, aggressive, ongoing process that can move charcoal fragments, pollen grains, and other small particles several meters through a soil profile over the course of a few thousand years. Termites alone, which are extraordinarily abundant in tropical Indonesia, can excavate and redistribute enormous volumes of soil, carrying particles from deep layers to the surface and vice versa in their endless tunneling. This meant, according to the critics, that the radiocarbon dates Danny Hillman had obtained were not dating the construction of any structure at all. They were dating organic material that happened to be present in the soil at those depths, material whose age reflected the age of the soil itself, not the age of any human activity associated with it. In other words, the critics were arguing that Danny Hillman had not dated the pyramid. He had dated the dirt. And if that criticism was correct, then the entire chronological framework of the study, the 14,000-year dates, the 27,000-year dates, all of it, collapsed into meaninglessness. The question was whether the journal and the scientific community at large would agree. They agreed. In March of 2024, the editors of Archaeological Prospection took the extraordinary step of formally retracting the Gunung Padang paper. Retractions in scientific publishing are rare and they are serious. They are not issued lightly. They are the nuclear option of academic quality control, reserved for situations where a paper is found to contain errors so fundamental that its conclusions cannot be trusted, and its continued presence in the scientific record is deemed harmful. The retraction notice stated, in the careful, measured language that scientific journals use when they are delivering what amounts to a professional death sentence to a piece of research, that the paper contained a quote major error unquote in the interpretation of the radiocarbon dating evidence, and that the conclusions reached by the authors were not supported by the data presented. In plain language, stripped of all the diplomatic hedging, the journal was saying that Danny Hillman's team had been wrong. The dates did not mean what they said they meant. The pyramid, if it existed at all beneath the surface of Gunung Padang, had not been proven to be ancient by this study. Now it is worth pausing here to talk about what a retraction actually is and what it is not, because this distinction matters enormously, and it is one that the general public and the media almost always get catastrophically wrong. A retraction does not mean the data was fabricated. It does not mean the authors committed scientific fraud. It does not necessarily mean the site itself is unimportant or uninteresting, or that nothing unusual is happening beneath the surface. What a retraction means, in its most precise and limited sense, is that in the judgment of the journal's editors and the external reviewers they consulted, the paper's interpretation of the data contains errors significant enough that the paper's conclusions are no longer considered reliable. The data itself, the radar images, the seismic tomography results, the core samples sitting in storage containers in Jakarta, all of that may still be perfectly valid, perfectly real, perfectly interesting. But the story the authors told about that data, the narrative that said this evidence proves this site is a 14,000-year-old pyramid, was judged to be unsupported by what the evidence actually shows. Danny Hillman and his co-authors did not go quietly. They publicly disputed the retraction, arguing that the critics had fundamentally misunderstood their methodology, that the journal had succumbed to political pressure from an archaeological establishment that felt threatened by their findings, and that additional evidence not yet published would eventually vindicate their claims completely. In the bruising, ego-driven world of scientific controversy, this kind of response is not unusual. Retractions are almost always contested by the retracted authors. Nobody wants to see their life's work, their career-defining discovery, officially declared unreliable by the very system they spent decades working within. But in the wider scientific community, the retraction was broadly seen as justified, and by many, as long overdue. The paper had been published, critics argued, with inadequate peer review, rushed through a process that should have caught the dating interpretation problem before the paper ever saw print. And this is where it gets really interesting, because the retraction did not actually settle the underlying question. It settled a specific, narrow, technical dispute about whether the radiocarbon dates in one specific paper reliably demonstrated that one specific site was built 14,000 years ago. The answer to that specific question, according to the consensus of the scientific community, is no. The dates as presented do not reliably demonstrate that. But lurking behind that specific technical dispute is a much larger, much more interesting, and much more difficult question that the retraction did absolutely nothing to answer. That question is this: is there something artificial beneath Gunung Padang that is older than the surface terraces that everyone agrees were built a few thousand years ago? Because here is what even the harshest, most aggressive critics of the retracted paper generally do not dispute. The ground-penetrating radar data is real. The seismic tomography data is real. Those instruments detected anomalies beneath the surface of Gunung Padang that are genuinely unusual for a natural volcanic formation in this geological setting. Distinct layers with sharp, well-defined boundaries, geometric patterns in the subsurface structure, possible enclosed voids at depth. The question is not whether those anomalies exist in the data. They do. The question is what they mean. Danny Hillman says they mean buried human construction. The geological critics say they could mean entirely natural processes that produce similar geophysical signatures, such as differential weathering of layered volcanic deposits, or underground water channels dissolving certain types of rock and leaving natural cavities, or the natural settling and compaction of volcanic debris over geological time, creating sharp density boundaries between layers. Both explanations are technically possible. Neither has been definitively proven or disproven. The situation at Gunung Padang after the retraction is something like a crime scene where everyone agrees that something unusual happened, but nobody can agree on what. The evidence is genuinely ambiguous. The data can be read in more than one way by competent, honest scientists who are looking at the same numbers and reaching different conclusions. But the story of Gunung Padang cannot be understood in isolation. It exists within a much larger geographical and historical context that makes the question of what lies beneath this Javanese mountain not just academically interesting, but potentially world-changing. Because Gunung Padang does not sit on just any piece of land. It sits on the remnant of something much larger, something ancient and drowned, and almost entirely unexplored. A vast landmass that was above water for tens of thousands of years during the Ice Age, and that is now hidden beneath the shallow, warm seas of Southeast Asia, a place scientists call Sunderland. To understand why Sunderland matters so much to the mystery of Gunung Padang, you need to understand what the world looked like 20,000 years ago, during the peak of the last Ice Age, a period scientists call the last glacial maximum. It was a world that would be almost unrecognizable to anyone alive today. Massive ice sheets, in some places 2 miles thick, covered most of Canada, the northern United States, Scandinavia, and northern Russia. The sheer volume of water locked up in those continental glaciers was staggering. So much of the planet's water had been pulled out of the oceans and frozen into ice on land that global sea levels were approximately 400 feet lower than they are right now. 400 feet. Think about what that means in practical terms. If you drained 400 feet of water from every ocean on Earth simultaneously, enormous expanses of what is currently seafloor would suddenly become dry land. Continental shelves that are currently submerged beneath shallow coastal waters would be exposed as vast, flat, habitable plains stretching for hundreds of miles out from the present-day coastlines. And nowhere on Earth was this effect more dramatic than in Southeast Asia. The region that we now call Indonesia, Malaysia, Thailand, Cambodia, and Vietnam looks, on a modern map, like a scattered archipelago, thousands of islands of various sizes separated by shallow seas. But those seas are extraordinarily shallow. The Java Sea, the South China Sea, the Gulf of Thailand, much of this watery expanse is less than 200 feet deep in many places. When sea levels dropped by 400 feet during the Ice Age, almost all of that water disappeared. The islands merged, the seas became dry land, and what emerged was not a scattering of barely connected land bridges, but a single, enormous, contiguous landmass roughly half the size of modern India, a subcontinent that has no equivalent in the world today. Scientists call it Sunderland, after the Sunda Shelf, the shallow continental shelf on which it sits. Sunderland was massive. It connected the Malay Peninsula to Borneo, to Sumatra, to Java, and to dozens of smaller islands that are now separated by water, where today there are straits and channels and busy shipping lanes. During the Ice Age there were river valleys and plains and forests. The modern island of Borneo, which is today the third largest island on Earth, was not an island at all. It was a mountain range, rising from the interior of a vast lowland plain. Java was not an island either. It was the southern coast of a continent that stretched north for over 1,000 miles to the mainland of Asia without interruption. Where Singapore now sits on the tip of a peninsula surrounded by busy waterways, during the Ice Age it would have been an inland city, hundreds of miles from the nearest coast. And this was not a barren, frozen wasteland. Sunderland sat near the equator. Even during the depths of the Ice Age, When much of the northern hemisphere was buried under glaciers, the equatorial regions remained relatively warm. Sunderland was covered in dense tropical and subtropical forests, interspersed with grasslands, savannas, and broad river systems that drained enormous watersheds. Multiple major rivers, rivers as large as the modern Mekong or the Ganges, flowed across the Sunderland lowlands, carving valleys, depositing rich alluvial sediment, and creating the kind of fertile, well-watered environments that tend to attract and sustain large human populations. The coasts of Sunderland, its actual Ice Age coastlines that are now 400 feet underwater, would have featured the same mangrove forests, tidal flats, coral reefs, and productive marine environments that make modern Southeast Asian coastlines among the most biologically productive on Earth. People lived here, that much is certain. Modern humans reached Southeast Asia at least 50,000 years ago, probably much earlier. Archaeological sites on Borneo, on Sumatra, on Java, and on the Malay Peninsula have yielded evidence of continuous human occupation stretching back tens of thousands of years. These were not small, marginal populations clinging to survival in a hostile environment. Southeast Asia during the Ice Age was a paradise for human habitation, warm, wet, rich in food, teeming with wildlife and marine resources. The population of Sunderland during the last glacial maximum is impossible to estimate with any precision, but it was almost certainly substantial, possibly in the hundreds of thousands or even millions, spread across a landmass the size of a small continent. And here is the crucial point. Here is the thing that makes Sunderland relevant to every question we are asking about Gunung Padang and about the origins of human civilization in general. Almost everything those people built, almost everything they created, almost every settlement they established, and every tool they fashioned, and every structure they erected on the lowland plains and the coastal zones of Sunderland is now underwater, 400 feet underwater. Buried beneath the warm, murky waves of the Java Sea and the South China Sea, sitting on the drowned continental shelf, covered in marine sediment and coral growth, largely inaccessible to conventional archaeology, unexplored, unmapped, and almost entirely unknown. We know virtually nothing about what happened on Sunderland during the tens of thousands of years when it was dry, habitable land, not because nothing happened there, but because the evidence is at the bottom of the ocean. It is one of the largest blind spots in the entire history of human archaeology, an area the size of a small continent, inhabited by an unknown number of human beings for at least 50,000 years, and we cannot dig there because it is under 100 feet of seawater. Whatever those people did, whatever they built, whatever they knew, it is hidden from us by an accident of climate, and that realization forces a deeply uncomfortable question. What if the people who lived on Sunderland during the Ice Age were more sophisticated, more organized, more capable than we have assumed? What if Gunung Padang, sitting on the high ground that remained above water when the rest of Sunderland drowned, is the one surviving fragment of something much larger that we simply cannot access? Sunderland during the Ice Age was not just habitable. It was one of the most biologically extraordinary places on the planet. The warm, equatorial climate meant that even as glaciers ground across Europe and North America, the lowlands of Sunderland remained lush, green, and teeming with an almost absurd abundance of life. The forests were dense and multi-layered, enormous dipterocarp trees rising 150 feet into the air, their canopies interlocking to form a roof so thick that the forest floor existed in perpetual twilight. Below the canopy, the understory was a chaotic tangle of ferns, vines, climbing palms, and flowering plants, all competing for the scraps of sunlight that filtered through from above. The rivers were wide and slow-moving, their banks lined with dense stands of bamboo and rattan, their waters thick with fish and freshwater turtles, and the occasional massive freshwater stingray, a species that still exists in Southeast Asian rivers today and can grow to 14 feet across. And the animals. Sunderland's megafauna during the Ice Age was a catalogue of creatures that seem almost mythological to modern eyes. Elephants roamed the lowland forests, not the relatively modest Asian elephants of today, but stegodon, an enormous, straight-tusked relative that stood 12 feet tall at the shoulder and weighed as much as a large African elephant. Giant tapirs browsed in the undergrowth. Sun bears, smaller than their northern cousins but still formidable, competed with civets and binturongs for fruit in the forest canopy. Tigers patrolled the grasslands and forest edges, apex predators of a landscape that provided them with an almost unlimited supply of prey. Orangutans, which today survive only on Borneo and Sumatra, ranged across the entire Sunderland platform, their population numbering in the hundreds of thousands or possibly millions, swinging through a continuous canopy that stretched for thousands of miles without interruption. But here is where Sunderland's story takes a turn that few people outside of paleoanthropology know about, and it is one of the strangest chapters in the history of our species, because modern humans were not the only intelligent beings living in Southeast Asia during the Ice Age. On the island of Flores, which during the last glacial maximum was separated from the Sunderland mainland by a deep water channel called the Wallace Line, a different kind of human existed. In 2003, a team of Australian and Indonesian archaeologists excavating a limestone cave called Liang Bua on Flores made one of the most astonishing discoveries in the history of paleoanthropology. They found the skeleton of a tiny human being, an adult female fully grown who stood approximately 3 feet 6 inches tall and had a brain roughly the size of a chimpanzee's. She was not a child. She was not a modern human with a growth disorder. She was a member of a completely separate species, a distinct lineage of the human family tree that had evolved in isolation on Flores for hundreds of thousands of years, shrinking in body and brain size through a well-documented evolutionary process called island dwarfism. They named her Homo floresiensis. The press called her the Hobbit, and she was not alone. The excavations at Liang Bua revealed that Homo floresiensis had lived on Flores for at least 700,000 years, overlapping with modern humans for thousands of years after our species arrived in the region. They made stone tools. They hunted stegodon, the same giant elephants that roamed the Sunderland mainland, though on Flores both the humans and the elephants had shrunk to miniature versions of their continental relatives. They used fire. They were, by any reasonable definition, a successful, intelligent, tool-using human species living right next door to Sunderland during the period when, if Danny Hillman is correct, someone on Java was building pyramids. And this is what makes the whole question of Ice Age Southeast Asia so tantalizing and so frustrating at the same time. We know that the region was home to at least 2 species of intelligent humans during the relevant time period. We know that modern humans in the area had the cognitive capacity for complex behavior, because modern humans everywhere had that capacity by 50,000 years ago. The cave paintings of Borneo, discovered in deep limestone caves in the eastern part of the island, have been dated to at least 40,000 years ago, making them among the oldest known examples of figurative art anywhere in the world. These were not crude scratches or random marks. They include detailed, naturalistic paintings of wild cattle and hand stencils, created with sophisticated techniques involving the preparation of ochre pigments and the use of blowpipes to spray paint onto the cave walls. The people who made these paintings were fully modern in their cognitive abilities. They could plan, abstract, symbolize, and create. The question is not whether they were capable of building complex structures. The question is whether they did, and if so, where is the evidence? Most of it, the overwhelming majority of it, is almost certainly at the bottom of the sea. The lowland river valleys of Sunderland, the coastal plains, the sheltered bays and estuaries where human populations tend to concentrate most densely, all of those environments are now under 100 or more feet of tropical seawater, covered in coral, silt, and marine sediment that has been accumulating for 10,000 years. No archaeological team has ever conducted a systematic underwater survey of the Sunda Shelf. The cost would be astronomical. The logistics would be nightmarish. The area is simply too vast, too deep in many places, and too murky to survey with existing technology in any comprehensive way. We are left with the fragments that survived above the waterline, the caves on Borneo, the highland sites on Java, the mountaintop terraces on islands that were once the peaks of an interior mountain range. And the one structure that sits on high enough ground to have survived the drowning of Sunderland, the one place where evidence of Ice Age construction might still be preserved in the dry volcanic soil of a Javanese hilltop, is Gunung Padang. Whether what lies beneath it is natural geology or the work of human hands remains the question that simply refuses to go away. The drowning of Sunderland was not a single catastrophic event. It was not a biblical deluge that swept across the land in a matter of days or weeks and swallowed everything whole. It was a process that unfolded over thousands of years, driven by the slow but relentless melting of the continental ice sheets that had locked up so much of the planet's water during the last glacial maximum. As the ice melted, water flowed into the oceans and the seas began to rise, slowly at first, inch by inch. Year by year, generation by generation, for most of the deglaciation period, between roughly 18,000 and 12,000 years ago, the rise was gradual enough that people living on the coasts of Sunderland might not have noticed it within a single lifetime. The shoreline would have crept inland imperceptibly, swallowing a few feet of beach here, flooding a low-lying marsh there. Nothing dramatic, nothing terrifying, just a slow, quiet retreat of the land before the advancing sea. But the melting was not constant. It came in pulses, and some of those pulses were fast enough to be genuinely terrifying. Around 14,600 years ago, there was an event that ocean scientists call Meltwater Pulse 1A. In a geological instant, enormous volumes of meltwater from the collapsing ice sheets poured into the world's oceans, raising global sea levels by roughly 60 to 70 feet in the space of 300 to 500 years. That translates to a rate of rise of more than a foot per decade. Over the course of a single human lifetime, the coastline could have retreated miles inland. Low-lying areas that had been dry, inhabited, productive land at the beginning of a person's life would have been underwater by the end of it. Entire river systems would have been swallowed. Forests would have been drowned, their dead trunks standing in expanding lagoons of salt water before finally collapsing into the rising sea. For people living on the flat, low-elevation plains of Sunderland, where even small changes in sea level translated into enormous losses of dry land because the terrain was so flat. Meltwater pulse 1A would have been an apocalypse in slow motion. Imagine being a member of one of the communities living on the Sunderland lowlands during this period. You are a fisherman, perhaps, or a gatherer, or a hunter who tracks game through the lowland forests. Your grandparents told you stories about places, settlements, fishing grounds, sacred sites that used to exist further out toward the coast, but that are now underwater. When you were a child, the sea was far away, a distant shimmer on the horizon. Now it is closer, noticeably closer. Every year, the water creeps a little further up the river valleys. Every monsoon season, the flooding reaches a little further inland than it did the year before, and when the floodwaters recede, they don't recede as far. The beach where you played as a child is gone. The headland where your grandfather fished is now an island surrounded by rising water. And the elders in your community, the ones who keep the oral histories and the sacred stories, are telling you that the sea is angry, that the spirits are displeased, that the land is being punished for some forgotten transgression. You don't know about ice sheets or orbital cycles or meltwater pulses. All you know is that the world is shrinking. The effects on Sunderland were catastrophic in their scale. Over the course of roughly 8,000 years, from the beginning of the deglaciation around 18,000 years ago to the stabilization of sea levels around 10,000 years ago, approximately 2.5 million square kilometers of dry land were submerged. 2.5 million square kilometers. That is an area roughly the size of the entire Mediterranean Sea. Every century, on average, thousands of square miles of inhabited territory disappeared beneath the waves. The great river systems that had drained the Sunderland lowlands were drowned one by one. The forests were killed by saltwater intrusion. The coastal ecosystems that had supported large human populations were destroyed and rebuilt further inland in a constant, exhausting retreat before the advancing ocean. The human populations of Sunderland had no choice but to move. They retreated to higher ground, to the mountainous interiors of what are now the islands of Borneo, Sumatra, and Java, to the coastal highlands that remained above water as the lowlands flooded. They crowded into shrinking areas of habitable land, competing with other displaced groups for resources that were diminishing with every passing generation. Some, almost certainly, took to the sea, using boats and rafts to follow the coastline, to seek out new territories, to escape the rising waters by moving to higher, drier land elsewhere. The drowning of Sunderland was one of the greatest forced migrations in human prehistory, an event that displaced millions of people over thousands of years and scattered them across the islands and coastlines of the Pacific and Indian Oceans. And here is the connection back to Gunung Padang. Java, unlike the flat lowlands of central Sunderland, is a mountainous volcanic island. Its highlands remained well above sea level throughout the entire deglaciation. Gunung Padang, sitting at an elevation of roughly 3,000 feet above modern sea level, was never in any danger of being submerged. If there were communities on Sunderland that had developed the organizational capacity and the technical knowledge to build large stone structures, communities that we cannot study because their lowland settlements are now at the bottom of the Java Sea, then the highlands of Java are exactly where we would expect to find traces of their work. The high ground is where they would have retreated as the waters rose. The high ground is where they would have carried their traditions, their building techniques, their sacred practices. And the high ground is where Gunung Padang sits, a mountain of strange hexagonal stones in the Javanese jungle, with anomalies in its subsurface that nobody can fully explain. The people displaced by the drowning of Sunderland did not simply vanish into the jungles of the surviving islands and fade from history. They became one of the most remarkable seafaring populations the world has ever known. Genetic and linguistic evidence tells a story that is breathtaking in its scope. The descendants of the Sunderland populations eventually became the Austronesian peoples, a vast cultural and linguistic family that, starting roughly 5,000 years ago, exploded outward from the islands of Southeast Asia in the most extensive maritime migration in human history. They sailed east across the Pacific, island hopping through Melanesia and Polynesia, reaching New Zealand, Hawaii, and Easter Island. They sailed west across the Indian Ocean, reaching the island of Madagascar off the east coast of Africa, 4,000 miles from their starting point. They colonized every habitable island in the Pacific Ocean, navigating thousands of miles of open water using nothing but the stars, the patterns of ocean swells, the flights of seabirds, and a body of navigational knowledge passed orally from generation to generation that rivals anything produced by European maritime technology before the invention of the chronometer. The Austronesian expansion is one of the great epic achievements of our species. These were not accidental drifters blown off course by storms. They were deliberate, systematic explorers who built sophisticated double-hulled canoes capable of carrying dozens of people along with livestock, seeds, and supplies for weeks at sea. They colonized island after island, adapting to wildly different environments, from the tropical atolls of Micronesia to the temperate forests of New Zealand, from the volcanic peaks of Hawaii to the dry grasslands of Easter Island. And they did it all without metal tools, without writing, without any of the technologies that Europeans would later consider prerequisites for long-distance navigation. The question that haunts the margins of this story is simple. Where did this extraordinary maritime capability come from? Skills this sophisticated do not emerge overnight. They develop over millennia through generations of accumulated experience, trial, error, and refinement. The Austronesian expansion of 5,000 years ago was the culmination of a tradition of seafaring and navigation that almost certainly stretches back much, much further. And that tradition almost certainly developed, at least in part, on Sunderland. During the Ice Age, when the lowland plains were above water, the people living there would still have been navigating rivers, crossing channels, fishing in coastal waters, and probably making short sea crossings between the Sunderland mainland and nearby islands that remained separated by deep water channels, such as Flores across the Wallace Line. The skills needed for open ocean navigation, the ability to read currents and winds and stars, the knowledge of how to build seaworthy vessels from the materials at hand, these things were almost certainly being developed on Sunderland long before the land was drowned. The catastrophe of the rising seas may have actually accelerated the development of maritime technology. When your homeland is disappearing under the waves, getting very good at boats very quickly becomes a survival imperative. But let us step back from the broad sweep of Sunderland's drowning and the Austronesian expansion and return to the specific, stubborn, infuriating question at the center of this story. Is there really something artificial buried beneath Gunung Padang? The paper was retracted. The dating was challenged. The mainstream archaeological community has largely rejected the claim. But has anyone actually proven that the claim is wrong? And this is where it gets really uncomfortable, because the honest answer is no. Nobody has proven it wrong. They have proven that one particular piece of evidence, the radiocarbon dates in one particular paper, does not reliably support the claim. But disproving one piece of evidence is not the same thing as disproving the claim itself. Here is what even the skeptics have to grapple with. The ground-penetrating radar data shows anomalies, real anomalies, patterns in the subsurface of Gunung Padang that are unusual for a natural volcanic formation. The seismic tomography shows density variations that are consistent with, though not proof, of layered construction. The core samples contain material that was, at the very least, ambiguous in its origin, material that could be natural, but that also has characteristics consistent with deliberate placement. No one has offered a completely satisfactory natural explanation for all of these anomalies taken together. Individual anomalies can be explained away. This one could be differential weathering. That one could be a natural cavity. This pattern could be coincidence. But the totality of the evidence, the fact that so many different independent measurements all point in the same unusual direction, has not been fully accounted for by any purely geological model. The honest scientific position, stripped of ego and tribal loyalty, and the career pressures that drive academics to take strong positions and defend them loudly, is that we don't know. We genuinely don't know what is beneath Gunung Padang. The evidence for a 14,000-year-old pyramid is weak and has been rightly criticized. But the evidence that the site is nothing more than a natural hill with recent megalithic modifications on top is also incomplete. The truth, as it so often does in science, probably lies somewhere in between, in a place that is too nuanced, too complicated, and too unsatisfying for either side to accept comfortably. What would settle the question is a proper, full-scale archaeological excavation of the deeper layers of Gunung Padang, conducted by an international team with no stake in the outcome, using modern stratigraphic methods that could determine definitively whether the subsurface arrangements of basalt columns are natural geological formations or the product of deliberate human placement. That excavation has never been done. The site is sacred to the local Sundanese community, and there are serious and legitimate concerns about disturbing it. The Indonesian government has been reluctant to authorize a dig that could damage a nationally important cultural site, particularly in the aftermath of the paper's retraction and the embarrassment it caused. And so the question remains open. Maddeningly, fascinatingly, stubbornly open. And Gunung Padang is not the only site on Earth that raises this kind of uncomfortable question about how old human construction might really be. In 1994, a German archaeologist named Klaus Schmidt visited a rounded hilltop in southeastern Turkey called Göbekli Tepe, which translates to Potbelly Hill in the local language. A survey team had examined the site briefly in the 1960s and dismissed it as nothing more than a medieval cemetery with some scattered stone fragments. Schmidt, looking at the same surface features with different eyes, disagreed. He began to dig. What he found beneath the surface of Potbelly Hill stunned the archaeological world and has not stopped stunning it since. Göbekli Tepe is a monumental stone complex consisting of massive T-shaped pillars, some standing 18 feet tall and weighing up to 20 tons, arranged in precise circles and decorated with elaborate carved reliefs of animals, abstract symbols, and enigmatic humanoid figures. It is, by any standard, a work of sophisticated architecture requiring significant organizational capacity, technical skill, and aesthetic vision. And it was built approximately 11,600 years ago. That date matters enormously. 11,600 years ago, the people who built Göbekli Tepe had not yet invented agriculture. They were hunter-gatherers. They had no permanent settlements. They had no pottery. They had no metal tools. According to the conventional understanding of human development that existed before Göbekli Tepe was discovered, people at this stage of cultural evolution were simply not capable of organizing the labor force needed to quarry, transport, carve, and erect 20-ton stone pillars. Monument building was supposed to come after agriculture, after permanent settlement, after the development of social hierarchies complex enough to direct large-scale construction projects. Göbekli Tepe shattered that assumption completely. It proved that hunter-gatherers, people living without any of the technologies and social structures that we thought were prerequisites for monumental construction, could and did build things that would remain impressive 11,000 years later. And here is why Göbekli Tepe is relevant to Gunung Padang. The discovery of Göbekli Tepe did not just push back the date of the oldest known monumental architecture. It fundamentally altered our understanding of what prehistoric people were capable of. Before Göbekli Tepe, if someone had told you that hunter-gatherers built a massive stone complex 11,000 years ago, you would have been justified in calling them a crank. After Göbekli Tepe, the response has to be different. We now know with absolute certainty, backed by decades of rigorous excavation and dating, that pre-agricultural humans were capable of feats of construction that would have been considered impossible by the archaeological establishment as recently as the 1990s. The question is no longer whether hunter-gatherers could build monuments. They could. The question is how far back that ability extends and where else it might have been exercised. Göbekli Tepe is not the only site that challenges comfortable assumptions. Off the southern coast of Japan, near the island of Yonaguni, divers in the 1980s discovered a massive underwater rock formation that features what appear to be flat terraces, right-angled steps, perfectly straight edges, and geometric shapes that look uncannily like the ruins of a man-made structure. The Yonaguni Monument, as it has come to be called, sits roughly 75 feet beneath the surface of the Pacific Ocean, in an area that was above sea level during the last ice age when sea levels were lower. If it is artificial, it would predate any known civilization in the region by thousands of years. Mainstream geologists generally consider the Yonaguni Formation to be natural, a product of the tendency of certain types of sandstone to fracture along flat planes and right angles, producing shapes that mimic architecture through purely geological processes. But the debate has never been fully settled, and the formation continues to attract divers, researchers, and controversy in roughly equal measure. Off the coast of western India, in the Gulf of Cambay, sonar surveys in 2001 detected what appeared to be the remains of a large settlement on the seabed, roughly 130 feet below the surface. Artifacts dredged from the site, including pottery fragments and what appeared to be worked stone, were dated to roughly 9,500 years ago, which would make the site significantly older than any known urban settlement in the Indian subcontinent. The Gulf of Cambay discovery has been heavily criticized on methodological grounds, with skeptics pointing out that artifacts dredged from the seabed cannot be reliably associated with any specific underwater formation, and that the sonar images are ambiguous at best. But like Yonaguni, like Gunung Padang, the site refuses to go away entirely. It sits there, underwater, unexplained, an irritant in the smooth narrative of human progress that mainstream archaeology would prefer to tell. The pattern, if there is a pattern, is suggestive. Around the world, in locations that were above sea level during the Ice Age but are now submerged or buried, there are formations and anomalies and artifacts that hint, without proving, that human beings were doing things before the end of the Pleistocene that our current models say they should not have been doing. Göbekli Tepe is the one case where the evidence is overwhelming and undeniable, where the excavation has been done properly and the dating is beyond dispute. But Göbekli Tepe may not be unique. It may simply be the one site that happened to survive on high, dry ground where archaeologists could find it. How many other Göbekli Tepes are sitting on drowned continental shelves around the world, buried under 100 feet of seawater, waiting for a technology that does not yet exist to find them? Nobody knows. And the fact that nobody knows is itself a kind of evidence. Not evidence for any specific claim, but evidence that our picture of the human past is incomplete in ways that we are only beginning to understand. There is a deeply ingrained assumption in modern Western thought that human history is a story of linear progress. We start as primitive cave dwellers, we invent agriculture, we build villages, we develop cities, we create writing, and we march steadily upward toward the pinnacle of civilization that we currently inhabit. Each stage follows logically from the one before it. Each innovation enables the next. The arrow of progress points in one direction, always up, always forward, always from simple to complex, from crude to sophisticated, from ignorant to enlightened. This narrative is so deeply embedded in our cultural consciousness that most people absorb it without ever questioning whether it is actually true. But it has a problem, a serious, fundamental, possibly fatal problem. It does not match the evidence. The cognitive revolution, the moment when the human brain became capable of symbolic thought, abstract reasoning, artistic expression, and complex language, occurred at least 70,000 years ago. Some researchers push it back further to 100,000 years or more. The oldest known examples of figurative art, the cave paintings of Indonesia and Europe, date to at least 40,000 years ago. The oldest known jewelry, shell beads carefully pierced and strung on cords, dates to roughly 80,000 years ago. The oldest known use of ochre pigment for body decoration dates to over 100,000 years ago. By any cognitive measure, humans have been fully modern, fully capable of everything that you or I can do mentally for at least 70,000 years. Now think about what that means. Agriculture was invented roughly 12,000 years ago. The first cities appeared roughly 6,000 years ago. Writing was invented roughly 5,000 years ago. That means that for at least 58,000 years, between the cognitive revolution and the invention of agriculture, human beings who were every bit as intelligent as we are lived on this planet, without doing any of the things that we consider the markers of civilization. Or did they? Because the absence of evidence is not the same as evidence of absence, and the archaeological record for those 58,000 years is almost laughably incomplete. We have cave paintings, we have stone tools, we have shell beads, we have a handful of burial sites and a scattering of campsites. From 58,000 years of fully modern human existence across an entire planet, that is almost nothing. It is a few scattered puzzle pieces from a puzzle that originally contained billions. Why is the record so sparse? because most of the things that ancient people built were made of materials that do not survive well in the archaeological record. Wood rots, leather decays, fabric disintegrates, bone crumbles. Anything made of organic material in a warm, wet environment can disappear completely within a few centuries, leaving no trace at all. The only things that survive reliably over thousands of years are stone, fired clay, and in extremely dry or cold environments, occasional fragments of organic material that were preserved by unusual circumstances. If ancient people were building sophisticated structures out of wood and thatch and animal skins, which is exactly what many indigenous peoples around the world were doing when Europeans first encountered them, those structures would leave almost no archaeological trace. They would simply disappear, absorbed back into the earth, indistinguishable from the soil around them within a few hundred years. And then there is the sea level problem. During the last ice age, coastlines were hundreds of feet lower than they are today. Human populations have always concentrated along coastlines for the same reasons they do now: access to marine food resources, ease of transportation, moderate climates. The settlements, the fishing camps, the boat-building yards, the trading posts that Ice Age humans almost certainly established along their coastlines are now under hundreds of feet of seawater. We cannot dig there, we cannot survey there. The evidence is, for all practical purposes, inaccessible. The archaeological record of the last 70,000 years of human existence is not a complete record of what humans did. It is a tiny, biased, fragmentary sample of what humans did, skewed heavily toward stone tools and cave paintings and highland sites that happen to be preserved, and missing almost entirely the coastal, lowland, and organic material-based activities that probably represented the majority of human cultural output. This matters for Gunung Padang because the debate about the site is ultimately not a debate about one hill in Java. It is a debate about how much we are willing to trust our current picture of the human past. If you believe that the archaeological record is essentially complete, that we have found most of what there is to find, and that the gaps in our knowledge are relatively small, then Gunung Padang is probably just a natural hill with some megalithic modifications from a few thousand years ago. The anomalies in the subsurface are geological, the radiocarbon dates are misleading, and the case is closed. But if you believe that the archaeological record is deeply, systematically incomplete, that vast swathes of human activity over tens of thousands of years have been lost to decay, sea level rise, and the simple impossibility of excavating every square mile of the planet's surface, then the question becomes much more interesting. Because in a world where most of the evidence has been destroyed, the absence of evidence for ancient construction does not prove that ancient construction did not occur. It only proves that we have not found it yet. And maybe, just maybe, the strange hexagonal stones of Gunung Padang are one of the places where we are getting our first, tantalizing, ambiguous glimpse of something that the rest of the record has failed to preserve. The story of Gunung Padang cannot be fully understood without understanding the political forces that have shaped it. Because this is not just a scientific debate. It never was. From the very beginning, Gunung Padang has been entangled with questions of national identity, cultural pride, and political power in a way that has distorted the scientific process and made it almost impossible to separate the evidence from the emotions surrounding it. Indonesia is a young nation, formally independent only since 1945, cobbled together from thousands of islands and hundreds of distinct ethnic groups that were unified less by shared culture than by shared colonial experience under the Dutch. Building a coherent national identity out of that diversity has been one of the central challenges of Indonesian politics for the last 75 years. And one of the ways that nations build identity is through history, through the story they tell themselves about who they were before, about the greatness of their ancestors, about the deep roots of their civilization in the ancient past. For Indonesia, this is a sore point. The conventional Western narrative of ancient civilization focuses overwhelmingly on Mesopotamia, Egypt, Greece, Rome, China, and the Indus Valley. Southeast Asia barely appears. The conventional timeline says that complex civilization in Indonesia begins with the arrival of Hindu and Buddhist influences from India roughly 2,000 years ago, implying that Indonesian culture is derivative, borrowed, imported from elsewhere. For many Indonesians, this narrative feels like a continuation of colonialism by other means, a European academic establishment telling them that their ancestors were primitive until they were civilized by contact with external influences. Enter Gunung Padang, the idea that Indonesia might be home to the oldest pyramid on Earth, a structure that predates anything in Egypt or Mesopotamia by thousands of years, is not just scientifically exciting. It is emotionally and politically intoxicating. It says that Indonesian civilization did not begin with foreign influence. It says that the ancestors of modern Indonesians were building monuments before anyone else on the planet. It says that Indonesia's place in the story of human civilization is not peripheral but central. You can imagine how that narrative plays in a country of 270 million people with a deep hunger for historical recognition. And it did play enormously. Danny Hillman's research at Gunung Padang was not funded by a neutral academic institution. It was funded by the Indonesian government with the active support and encouragement of then-President Susilo Bambang Yudhoyono. The president visited the site personally. He spoke publicly about the importance of the research. He framed the project in explicitly nationalistic terms as a matter of Indonesian pride and identity. Government funding for the project was generous and came with the implicit expectation that the results would be, shall we say, favorable to the narrative of Indonesian greatness. This is not a conspiracy theory. It is well documented. Multiple Indonesian archaeologists spoke out publicly about the political pressure they felt to support claims about Gunung Padang that they believed the evidence did not warrant. Some were warned that challenging the project could have consequences for their careers and their funding. This political dimension is critically important because it is the thing that makes the Gunung Padang controversy so difficult to resolve cleanly. When science becomes entangled with national identity and political power, the normal mechanisms of scientific self-correction, peer review, replication, open debate become distorted. Researchers who support the politically preferred narrative receive funding, attention, and official support. Researchers who challenge it face marginalization, career consequences, and public hostility. The retraction of the 2023 paper was, in part, a corrective to this distortion, the international scientific community asserting that evidence matters more than nationalism. But the retraction also fed into a different narrative, the narrative that Western academia is biased against non-Western discoveries, that the archaeological establishment is protecting its own turf by dismissing evidence that challenges the conventional timeline. that the retraction was an act of intellectual colonialism rather than scientific quality control. Both of these narratives contain elements of truth, and both of them contain elements of self-serving distortion, which makes the whole situation almost impossibly complicated to untangle for anyone seeking an honest, balanced understanding. The political pressure on Danny Hillman's team was real and almost certainly did influence the way the research was conducted, the way the results were interpreted, and the confidence with which extraordinary conclusions were drawn from ambiguous evidence. But it is also true that Western archaeology has historically been dismissive of evidence from non-Western contexts, slow to take seriously the possibility that complex cultural achievements might have occurred outside the traditional centers of civilization recognized by European scholarship, and resistant to paradigm shifts that challenge the comfortable, familiar narrative of human development that places Europe and the Near East at the center of everything important. The truth, as usual, is messy and uncomfortable and refuses to fit neatly into anyone's preferred story. The science at Gunung Padang was compromised by politics, but the political critique of the science, the argument that the international establishment was too quick, too eager, too gleeful in its dismissal of the evidence, is not entirely without merit either. The speed with which Western academics pounced on the paper, the savagery of some of the public criticism, the barely concealed satisfaction in some quarters when the retraction was announced, all of it carried undertones that went beyond dispassionate scientific evaluation. There were egos involved. There were reputations to protect. There were entire careers built on a specific version of the human past that did not include Ice Age pyramids in Java, and those careers were being defended as fiercely as the Indonesian nationalists were defending their own narrative. And caught in the middle of all of this noise, all of this shouting, all of these competing agendas and wounded prides and institutional power games, sitting quietly on its hilltop in Western Java, surrounded by jungle and birdsong and the slow drip of monsoon rain, is a mountain of hexagonal stones that is not talking, that is not taking sides, that is simply existing as it has existed for a very, very long time, waiting with infinite geological patience for someone to come along and figure out what it actually is. There is a particular quality to Gunung Padang that no photograph can capture and no scientific paper can convey. It is a quality that you can only experience by being there, by standing on those upper terraces in the late afternoon when the light turns golden and the shadows lengthen across the fields of hexagonal stone. The jungle noise softens as evening approaches. The cicadas shift their pitch. The air cools by a degree or two, just enough to notice, just enough to feel like a change is coming. And the stones themselves seem to change too, their dark surfaces catching the low sunlight in ways that emphasize their geometric regularity, their hexagonal cross-sections, their uncanny precision. In certain light, at certain angles, they look undeniably natural volcanic columns produced by the physics of cooling magma, identical to columnar basalt formations found all over the world. But in other light, from other angles, with the terraces stretching before you in their neat, stepped progression and the retaining walls running in straight lines across the hillside, they look equally undeniably intentional. The ambiguity is part of the experience. The sight refuses to resolve into one thing or the other. It hovers in between, like an optical illusion that shifts between two images depending on how you look at it. The Sundanese people who have lived around Gunung Padang for generations do not experience this ambiguity. For them, the question of whether the site is natural or artificial is not particularly interesting or relevant, because their relationship to the mountain is not based on geological analysis or archaeological interpretation. It is based on something older and deeper. They know the mountain is sacred. They know it is a place of power. They know this not because a scientist told them or because they read it in a paper, but because their grandparents knew it, and their grandparents' grandparents knew it, and the knowledge goes back so far that its origin has been lost, replaced by legends that serve as containers for truths too old to be expressed in any other way. The story of King Siliwangi and the palace that turned to stone is not a historical account. It is a myth, and myths are not lies. Myths are the language that cultures use to encode information that is too important, too profound, or too ancient to be trusted to ordinary memory. When the Sundanese say that a king tried to build a palace here and that the palace was turned to stone by a curse, they may be preserving, in the only form available to them, a memory of something that actually happened on this hilltop so long ago that the details have been replaced by symbols. Oral traditions around the world have proven, time and again, to contain genuine historical information that predates the written record by thousands of years. Aboriginal Australians tell stories about a time when the sea was far away and you could walk to islands that are now surrounded by deep water. Those stories correspond precisely to the geography of Australia during the last ice age, when sea levels were lower and the islands were indeed connected to the mainland by dry land. The stories have been transmitted orally for at least 10,000 years, possibly much longer. In North America, indigenous oral traditions describe massive floods and landscapes covered in ice that correspond to events at the end of the Pleistocene. In each case, the scientific community initially dismissed these traditions as mere folklore, entertaining stories with no factual basis, only to discover later that they contained accurate descriptions of real events that occurred thousands of years before anyone thought oral memory could reach. The Sundanese tradition that Gunung Padang is a sacred, constructed ancient site may be another example of the same phenomenon. The legend of King Siliwangi places the construction in the 15th century, but the archaeological evidence for the surface terraces suggests they are several thousand years old, which means the legend has already been compressed in time, a common feature of oral traditions where ancient events are attributed to more recent, better-remembered figures. If the surface terraces are 3,000 years old and the legend attributes them to a 15th century king, what does that tell us about the deeper layers, the ones that Danny Hillman's radar detected beneath the surface? Could the oral tradition be preserving a memory that is not just older than the legend suggests, but vastly, incomprehensibly older? There is a stone on one of the upper terraces of Gunung Padang that pulls you back to the present moment and reminds you why this place feels different from other archaeological sites. The Batu Kekapi, the singing stone. It is a flat slab of andesite, roughly 3 feet long, slightly curved, resting on the ground among hundreds of other similar stones. But when you strike it, when you bring your knuckles down sharply on its smooth, dark surface, it produces a note. A clear, bright, ringing note that seems to come not from the surface of the stone, but from somewhere deep inside it. A sound that is more like a bell than a rock. A sound that hangs in the humid air for seconds before slowly fading into the ambient noise of the jungle. The local guides smile when they show this to visitors. They know the effect it has. They have seen it 1,000 times, the widening of the eyes, the involuntary laugh, the immediate desire to strike the stone again to make sure it really happened. The batu kekapi is not magical. The sound is produced by the stone's particular mineral composition and crystal structure, which happen to be arranged in a way that allows the stone to resonate at a specific frequency when struck, the same basic physics that makes a tuning fork work, but knowing the physics does not diminish the experience. If anything, it deepens it. Because you find yourself wondering, standing there on a terrace of hexagonal stones in a Javanese jungle, listening to a rock sing, whether the people who arranged these stones on this hilltop knew about this property, whether they chose this particular stone and placed it here because they knew it would ring, whether the singing stone was always part of the design, a voice built into the structure itself, a message encoded not in words or symbols, but in pure sound, placed there by someone who understood that long after everything else had been forgotten, the mountain itself would still be singing. Here is what we know for certain, stripped of all speculation, all politics, all romantic fantasies about lost civilizations, and all defensive hostility from academic gatekeepers. Gunung Padang is a real site. It exists. You can go there. You can climb the 370 steps and stand on the terraces and strike the singing stone and feel the humid air wrap around you like a living thing. The surface of the site consists of 5 terraces made from columnar basalt, arranged in stepped formation, modified and shaped by human hands at some point in the past, most likely between 2,000 and 4,000 years ago. This is not in dispute. Nobody questions that the surface features of Gunung Padang were constructed by human beings. The question is whether there is something older beneath them. We know that ground-penetrating radar and seismic tomography surveys detected anomalies in the subsurface of the hill. These anomalies are real. They are recorded in the data. They show layered structures with sharp boundaries, geometric patterns, and possible voids at depth. These features are unusual for a natural volcanic formation in this geological context. They are not, on their own, proof of human construction, but they are also not easily explained by any purely natural geological model that has been proposed so far. We know that core samples extracted from the hill contained layers of columnar basalt at depth, some of which appeared to be deliberately arranged, interspersed with layers of clay and organic material. We know that radiocarbon dating of organic material from those deeper layers returned dates ranging from approximately 7,000 to 27,000 years before the present. And we know that the interpretation of those dates as evidence of ancient construction was challenged by the scientific community, and that the paper presenting those dates was formally retracted by the journal that published it. What we do not know is what would happen if someone conducted a proper archaeological excavation of the deeper layers of Gunung Padang. Not a geophysical survey, not core sampling, a real excavation with trenches and stratigraphy and careful documentation of every layer, every artifact, every stone, conducted by an international team of qualified archaeologists and geologists with no political agenda and no career stake in the outcome. That excavation has never been done. Until it is done, the question of what lies beneath Gunung Padang will remain unanswered, and both sides of the debate will continue to fill the silence with their preferred narratives. We know that Sunderland, the vast Ice Age landmass on which Gunung Padang sits, was home to large human populations for tens of thousands of years. We know that those populations were cognitively modern, capable of art, complex tool-making, and long-distance navigation. We know that the overwhelming majority of the land they inhabited is now underwater, inaccessible to archaeology, and that whatever they built on those drowned lowlands has been hidden from us by the rising seas. We know that the one confirmed case of pre-agricultural monumental construction, Göbekli Tepe in Turkey, proved that hunter-gatherers were capable of feats of engineering that the archaeological establishment had previously considered impossible. And we know that the archaeological record of the last 70,000 years of human existence is profoundly incomplete, biased towards stone tools and highland sites, and missing almost entirely the coastal and lowland environments where most humans actually lived. None of this proves that Gunung Padang is a 14,000-year-old pyramid, but all of it, taken together, creates a context in which such a claim is not as absurd as it might initially seem. The claim may be wrong, it may even be very wrong, but it is not crazy. It is not outside the realm of what we now know human beings were capable of during the period in question. And the inability of the scientific community to definitively resolve the question, to either confirm or conclusively disprove the existence of ancient construction beneath the site, is itself a testament to how little we actually know about what our ancestors were doing during the vast, dark, largely unrecorded millennia that preceded the invention of writing. The story of Gunung Padang is, in the end, not really a story about one hill in Java. It is a story about the limits of knowledge itself. It is a story about the gap between what we know and what we think we know, between the evidence we have managed to preserve and the evidence we have lost forever, between the confident narratives we construct about the past and the vast, humbling, almost terrifying uncertainty that surrounds them on every side. We have been modern humans, fully modern in every cognitive sense, for at least 70,000 years. We have written records for about 5,000 of those years. That means we have documentation for roughly 7% of our existence as a thinking, symbolizing, creating species. For the other 93%, we are essentially guessing. We are making educated inferences from scattered fragments of bone and stone and charcoal, filling in the enormous gaps with assumptions and models and best guesses that may or may not bear any resemblance to what actually happened. We tell ourselves that the gaps are not that important, that the big picture is clear even if the details are fuzzy, that nothing truly significant could have occurred during those 65,000 undocumented years without leaving some trace in the archaeological record. But Göbekli Tepe was buried for 11,000 years before anyone found it. The cave paintings of Borneo were unknown to Western science until 2014. New discoveries that overturn decades of established thinking are being made every year, and every single one of them comes with the same humbling realization. We did not know what we did not know, and we still do not know how much we still do not know. Gunung Padang, whatever it turns out to be, is a reminder that the gaps in our knowledge of the human past are larger than we usually care to admit, and that what lies inside them may be far more surprising than we are currently prepared to accept. Close your eyes for a moment and go back to where we started. You are standing at the base of a mountain in western Java. The air is warm and heavy with moisture. The insects are humming their endless, droning song. The smell of wet earth and decomposing leaves and volcanic stone fills your nostrils. In front of you, disappearing upward into the dense green canopy, 370 steps of dark hexagonal basalt climb the face of the mountain toward whatever waits at the top. You have been here before, at the beginning of this story, but now you know things you did not know then. You know about Danny Hillman and his ground-penetrating radar and the data that looked like buried chambers. You know about the radiocarbon dates that suggested construction activity 14,000 years ago, and about the scientific community that challenged those dates and the journal that retracted the paper. You know about Sunderland, the drowned continent that lies beneath the shallow seas around you, a vast world that was home to untold numbers of people for tens of thousands of years before the rising ocean swallowed it whole. You know about Göbekli Tepe and the Yonaguni Monument and the cave paintings of Borneo and all the other fragments of evidence that suggest the human past is deeper, richer, more complex, and more mysterious than any textbook has ever told you. And you know something else too. You know that none of it has been resolved. The question that brought you to the base of this mountain, the question of whether something ancient and artificial lies buried beneath these hexagonal stones, is still open. It may remain open for a very long time, perhaps for decades, perhaps for generations. Perhaps until some future technology allows us to see beneath the surface of the Earth with a clarity that current instruments cannot achieve, or until an international team of archaeologists is finally given permission to excavate the deeper layers of this sacred, contested, endlessly debated site. Until then, Gunung Padang will remain what it has always been, a question mark carved in stone. A place where the known and the unknown overlap, where the line between geology and architecture, between nature and human intention, blurs and dissolves and refuses to be drawn with any confidence. The mountain does not care about our debates. It does not care about retracted papers or competing theories or the egos of scientists or the ambitions of politicians. It was here before any of them, and it will be here long after all of them are gone. The hexagonal columns will continue to sit in their strange, geometric rows, catching the light and the rain and the slow growth of moss. The jungle will continue to press in from every side, patient and relentless, swallowing the terraces inch by inch the way it swallows everything that holds still long enough. And somewhere on the upper terrace, the singing stone will continue to ring when struck, sending its clear, bright note out across the treetops and the river valleys and the rice paddies of Western Java, a sound that has no message, or maybe has a message so old that we have forgotten how to read it. There is something deeply comforting about questions that do not have answers. Not every mystery needs to be solved. Not every puzzle needs its final piece. Sometimes the most valuable thing a mystery can do is remind us that we do not know everything, that our maps of the past have blank spaces in them, that the story of human civilization is not the neat, linear, fully understood narrative that we sometimes pretend it is. Gunung Padang is one of those blank spaces. And maybe that is enough. Maybe it is enough to know that there is a mountain in Java made of hexagonal stones that might, or might not, be concealing something extraordinary beneath its surface. Maybe it is enough to hold the question without demanding the answer, to sit with the uncertainty the way the Sundanese have sat with the mystery of their sacred mountain for centuries, acknowledging that some things are older and stranger and more wonderful than our current tools can measure. Tonight, as you lie here listening to these words, as the weight of the day slowly lifts from your shoulders and your thoughts begin to soften and blur at the edges, think about what lies beneath things. Beneath the surface of the ground you walk on every day, there are layers of history that no living person has ever seen. Beneath the waves of the ocean, there are landscapes where your ancestors once walked, coastlines where they built their camps and launched their boats and watched their children play in the surf. Beneath the stories we tell ourselves about the past, there are other stories, older stories, stories that have been buried by time and water and the slow accumulation of everything that has happened since. We are standing on top of a history that is deeper than we know, and every now and then, in places like Gunung Padang, the depths send up a whisper, a vibration, a ringing note from a stone that should not be able to sing, and we are reminded that the ground beneath our feet is not as solid as we thought, that there are mysteries down there in the dark, patiently waiting. If you enjoyed tonight's journey through the jungles of Java and the drowned plains of Sunderland and the fierce, fascinating debates of modern archaeology, subscribe to our channel and we will see you in the next one. There are more mysteries waiting, more questions without easy answers, more strange, beautiful, impossible places hiding in the margins of the world we think we know. Until then, sleep well. Let the singing stone carry you into the dark and dream about what lies beneath. Good night.